Well, it's Tip Thursday. In today's Tip Thursday, I've got, let's see here, 1, 2, 3, 4, 6 tips. I'm going to do this video by using an actual project that Vectrix supplies in their software with vCarve Pro. So let's go through the 6 tips. The first tip is when you're setting up your resolution, use the lowest resolution you can for the project you're doing. If it's not a 3D project, then going above standard resolution is not really worth doing because it can slow the computer down. Tip number 2 is I wanted to point out the games that are available to anybody that has vCarve Pro that they can easily carve. Tip number 3 is validate the vector layers after they're imported. Vectrix will set up the projects in layers for you, but sometimes those layers aren't what is expected. Tip number 4, when you set up the molding toolpath, you need to make sure those vectors are correct too. In this case, you'll see when I set up the project, the molding toolpath for carving, that we're going to have a problem and I have to correct that, and I'll show you how. Step number 5 is use variables whenever possible, such as Z or T for thickness. Tip number 6 is a general rule for ramping a bit is 2 times the diameter of the bit. Why would you ramp? I generally ramp whenever I'm doing profile cuts to help avoid dwell marks as much as possible. I'm now going to show you how all of these tips apply to the project of cutting out a cribbage board that Vectrix already supplied. So let's go do this thing. I'm going to cover the tips by going through an actual project that Vectrix supplies to us. And that will be a cribbage board. I know that many people are interested in cribbage boards, so let's go through it. We're going to set up the material. I know the cribbage board original design is 4 by 13, so I'm going to set this up with a width of X of 5 and a length of 15. It's a 3/4 inch board. We're going to go off the material surface. I normally zero off the left corner on my projects. Our standard fastest modeling resolution is fine. We're doing no 3D scaling or anything. So we hit OK and we're all set. We can find the game layouts that Vectrix supplies to us in the Clip Art tab. So I'm going to come over to the Clip Art tab and I'm going to pick 2D game layouts. I'm going to pick the cribbage board they supply us. Double click on that, or I could have just drug it in. Now I'm going to go over to the drawing tab since the rest of the stuff I'm going to do is there. I'm first going to check out the file that Vectrix gave us, and I can see that it's already got layers. And so we've got peg holes, molding vectors, and a profile cut. So let's see what's in each of these layers. That's a good practice. When you've got layers, check to see what's in them. Peg holes, we would think, is all of the holes. Molding vector is the profile vector or the profile of the mold that was out here, and then this other vector inside for the drive rail. We'll get to that in a second. So there's the molding shape and there's the drive rail, and the profile cut is the outside vector we're going to cut the project out with. So the next step is to start setting up the toolpath. Let's start with the holes. You'll notice they're grouped, so I want to ungroup them. So I can either hit U for ungroup, or I could select ungroup over here. Now that I have the holes selected, I'm going to go over to the drill toolpath. I'm going to go down 0.55 inches. I'm going to use a 1/8 inch drill bit, and I'm going to select them manually one way, or the other way I could do it if I wanted to was use the selectors. I would select the holes by going to close vectors, only circles because they're all circles, associate with the toolpath. Then I would hit peg holes, hit close, hit calculate, and I'm going to put this as peg holes. Then I'll preview it, and there's the peg holes. Everything looks good. The next thing I want to do is do the molding toolpath. To do the molding toolpath, I will select the molding toolpath here. And you'll notice it says I need to select the drive rail. This would be the drive rail here. And then I need to select a profile, a molding profile. So I'm going to select this drive rail, and I'm going to select this molding profile, and I'm going to look at the setup. I want it right to the top. That's good. The gap below, that just happens to be the size of the vector. It's a 0.75 piece of wood, and you can see the depth of the vector is 0.25. I'm going to use a tapered ball nose, a 1/8 inch tapered ball nose. Let it vary the step over. And then I'm going to use the automatic boundary. I've already selected the drive rail and the profile rail manually, so it says manual, and I could hit molding path. And before I actually calculate and show you the results, I want you to notice one thing. The molding profile has a backside. So what you should expect to see because of this is that the drill bit will try to recreate this. So the turbine ball nose will come here, and what we will see when I calculate this is something like a juice groove back here where the bit went down to make this steep back. That's not what we're really going to want, but there's another tip to check the vectors that are in the pre-supplied clip art to make sure that they do what you want it to do. In this case, you're going to need to fix it, and let me show you why. So I'm going to hit calculate, and now we've got our molding toolpath calculated using the vector supplied. If I hit preview the visible toolpath, you can see what I was talking about here. There's that back of that vector right in here. So that's not what we want, because we want it to go straight from the flush top side of the holes, or the flush top side of where the holes are. So now let's go back and fix that. So we'll go back to the 2D section. I'm going to come into this vector, click on it, hit the node N, or over here I can select node here, either way. I'm going to select that vector with my right mouse click. I'm going to delete the span, or let me undo that. In this case, it's such a simple vector, I could have selected this node and hit delete point, and that would have done it also, just two different ways. And now what's going to happen is the bit's going to not try to create this, it's just going to go straight from here and follow this path. So let's recalculate that toolpath. It's already got the drive rail selected, it's already got the molding profile, so we don't have to redo anything there. We're going to hit calculate. We're going to reset the preview, and we're going to preview the visible path. And now you can see the molding looks just like we want it to. And I'll do the holes just so you can see how it looks. All right, so now we've got the cribbage board pretty much done. All we have to do is cut it out. So we're going to do that next. We're going to come over to the profile toolpath. Now that we have the holes in the molding toolpath, we're going to go ahead and calculate the outside profile. So we're going to select the profile. I'm going to select the profile toolpath. I'm going to go down the thickness of the material. That is either a Z or T. I'm going to use a 1/4 inch ball nose. I'm going to go on the outside of the vector. I'm not going to do a separate last pass. I'm not going to add tabs. I am going to add a ramp of 2 times the diameter of the bit for 0.5 to minimize dwell marks. I'm not going to select the vectors automatically in this case. I'm going to put cutout so I know what it is, and I'm going to hit calculate, and now I'm going to preview that path. So that looks good. Let's go ahead and preview the other 2 paths so we see a complete board. So that's what the cribbage board is going to look like when we're all done. Looks pretty good to me. And now you have a completed cribbage board. If I was going to do this as a real project, I would have gone ahead and added in text. But to do that, you actually need to make the cribbage board a little bit longer so you can make room for text and grid lines, etc.